Hi, Mister. God bless you. Today in this news, we'll start talking about an interesting thing named Aryl Halides. Our group is constituted by Victoria Valladares, Giovanna Valeriano, and me, Victor Romero.
Aryl Halides. In organic chemistry, an aryl halide, also known as halorine, is an aromatic compound in which one or more hydrogens atoms are directly bonded to an aromatic ring are replaced by a halide. Are much less reactive than a simple alkyl halide since they do not usually undergo simple nucleophilic substitution except for undergo very specific conditions. The word aryl means aromatic. Ring in the word halide means halogen of some sort: fluorine, chlorine, bromine, and iodine. When you're looking at an aryl halide, it's simply one of the four halogen atoms bonded directly to a Ising ring. The aryl halides are insoluble in water and are denser than water and form a separate level layer. The molecules are quite large compared with the water molecules. Moreover, the quite strong band there wall dispersion forces between chlorobenzene molecules will have to be broken. Both of these cause energy. The only new forces between chlorobenzene and the water will be van der Waals dispersion forces. These are not strong as hydrogen bonds or original dispersion forces in chlorobenzene. Arylation is a process in which an aryl group is attached to a substituent. It's typically achieved by cross-coupling reactions. Aryl halides have a halogen directly bonded to a carbon of an aromatic ring. Examples: bromobenzene, fluorobenzene, and 2,4-dichloromethylbenzene. Some of the methods in which alkyl halides are prepared do not work for the aryl halides because it's difficult to form C-halogen bonded an aromatic ring carbon by nucleophilic displacement reaction.
Thank you, Giovanna. Now we will start talking with our special guest, a scientist, especially a chemist named Victoria Valladares.
Hi, I'm glad to be here. And today I'm going to talk about the aryl halides. Aryl halides are termed halorines in the iodine nomenclature system. The prefix halo, bromo, fluoro, iodo, or fluoro is placed before the name of the aromatic hydrocarbon. In the case of the substituted compounds, the related positions are indicated by 1,2, 1,3, or 1,4. Ortho, meta, and para are also used to indicate the positions, for example, fluorobenzene or bromobenzene. Also, the most common elements included the aromatics such as the aryl halides are the fluoride, chloride, bromide, and iodine. Aryl halides are often react via the intermediacy of enzymes. Fluorobenzenes and sodium amide react in the liquid ammonia to give an aniline by this pathway. All these elements are based in benzene, therefore, the benzene ring is selected as the senior parent structures for the preferred iodide name and the compound given by the question, which leads to the chromobenzenes or fluorobenzenes. Now, the use of the appearance of aryl halides in real life is most common in nature, but most common in marine organisms that utilize that chloride and bromide in ocean waters. Chlorinated and brominated aromatic compounds are also numerous, for example, the derivatives of tyrosine, tryptophan, and various parallel of derivatives. Some of these naturally occur in aryl halides exhibit useful for medicinal properties. By the way, the aryl bromides are widely used to the fire retardants. The most prominent member is the tetrabromobisphenol, which is prepared by the direct bromination of a diphenol.
Now, as Victoria and Giovanna said, we will start talking about the aryl halides. Aryl halides are a really interesting topic because we can start talking about all the aromatics in each side. So first, I will start exemplifying every example of the most common examples of the aryl halides. So, follow me. First, we will start talking about the benzene. The benzene is the main structure in the aryl halides. This is represented as an hexagon. Also, it have a double bonding in some parts. And each side we have an alkyne. Each side is represented by H, such as hydrogen. So, benzene, as we already said, is represented such as H and have a straight skeletal column made of carbons. So, we have many different examples of aryl halides. These are really interesting because are really simple, but really, really different from other topics that we have saw in chemistry. So first, as you see in the screen, we have benzene. But what happened if you start adding, as Victoria said, you start adding different elements? Look at it. First, we'll start adding fluorine. As Victoria said, and also Yadvana, we have different types of Aryl halides. These are based in benzene, and we have 4 different elements. These 4 different elements are fluorine, chlorine, bromine, and iodine. So in the example you're seeing in screen, we have fluorine. What this will be named to us. So this Aryl halide will be named. We have the base name as benzene, and also we add the first name, such as fluoride, but different, such as fluoro. So its name will be named as fluorobenzene. Now, we have a different example. We doesn't just have fluorine, we also have another example. The other example will be chloride. So you add Cl, such as the chloride element, and then it won't be named chlorine benzene, it will be named chlorobenzene. This is really interesting because we have different types of bondings in each Aryl halide type in the benzene. Now, what happens if we add instead of in the top of the benzene, we add in other side or in other bonding? For example, I will erase this hydrogen, and now I will add, in this case, bromine, Br, in other side. This will always be will be an Aryl halide by a different name. It will be bromo because of bromine and bromobenzene. Now, the other example we can show is iodine. The iodine, as you know, is represented by the letter I, and the Aryl halide will be named as iodobenzene. Now, we have the basis of the 4 different elements that we can use as the basic types of Aryl halides. Now, we have a different and complex, semi-complex example. This example, we can add, for example, chlorides. So I will erase this part. We know that here also it will be based by a benzene. So I will erase this hydrogen and also this one. Now, we can add, as I said before, chlorine. So Cl as the representation of chloride in both sides. We will add chloride in both sides, and this won't be named chlorobenzene. In this case, it will be named because, now I'll explain it. In the first part, we have the first chain, now the second one, third part, the fourth one, the fifth one, and the sixth one. So, if you see, we have chloride in the second one and chloride in the fourth one. And these will be named, as we saw in chemistry class, 2, 4, dichloro with the hyphen, chlorobenzene. Why? Because we have the bonding in the second chain and also in the fourth one. So it will be represented as 2,4 dichlorobenzene. So this is the most basic topic of Aryl halides. Benzene can be represented, in this case as Aryl halides, can be represented by a double bonding or as a circle inside the hexagon. So, we studied basic types of Aryl halides. Thanks for your attention and God bless you.